quantity. Are you guys ready for the class? So we have 4 people that started the class now. That's good. So we can't wait for others again. We just have to proceed with the class. So, like I said, there were some issues we had in the last class, and I would like to start from there. And I will want you to actually pay maximum attention to this because we need to move on as fast as we can. So let's just continue with the chemical bonding. I gave you some notes in the last class. However, I would like to explain again. So chemical bonding. So when I was explaining last week, if you can remember, I was explaining to you that the essence of chemical bonding is that atoms want to have a stable octet structure. Atoms want to behave like a noble gas. You know, noble gases, if you remember, can you mention the example of noble gases? Let me just, atoms want to become stable. They want to become stable, like the noble gas. So that is the essence of this chemical bonding. Every reaction, every interaction between atoms, what they actually want to do is that they want to have a stable octet structure. You know, if you remember the octet rule says that we need 8 electrons in the outer shell or 2 electrons for the first shell. This to remember. So atoms want to become stable like the noble gas. If you remember the noble gases example, like helium, you know, helium has 2 electrons, right? At the outermost shell, isn't it? And that's the first shell, and it is complete, right? Another example is neon. Neon belongs to element number 10, is element number 10 in the periodic table. That's 2,8, right? So if you are writing this out, you know, you first draw the first shell. After drawing the first shell, you will put the first electron here, isn't it? Then you draw the second shell. So since it's 8, you will first make sure that everything is complete on the first side. 1, 2, 3, 4, 5, 6, 7, 8. Do you see it? That's 2,8, right? You can see that it has 8 electrons in the outermost shell, isn't it? Are you guys with me? So this is Leon. This next one is, we have other ones, but for the first 20 elements for your level, I think the last one is argon, right? Argon is 2,8,8 because it belongs to it's the atomic number 18, the 18th element in the periodic table. So if you are writing this argon, for example, since it's 2,8,8, you know, it will be 2, the second shell, because it has 1, 2, 3. Isn't it? So we have 2 at the first shell, 2 electrons. At the second shell, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And at the last shell, we have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now, can you see that this Leon here has a complete octet structure? 8 in the outermost electron, in the outermost shell. You can see the argon here also has a complete octet structure. Now, this is the idea in chemical bonding. Every atoms bond because they want to have this structure that we drew here. Please, do you get the concept? So anytime you are doing one chemical bonding or the other, the ionic bond, the covalent bond, the metallic, the hydrogen, and the coordinates, anyone, they want to have an octet structure. They want to obey the octet rule. Please, is that taken? So that is the reason why we have chemical bonding. Now, this is another cheat. Let me just draw a box for you. Okay, let me just draw a box here. There are some atoms that can transfer electrons. They cannot share. The only thing they can do is to transfer. They can transfer an electron in order to have that octet structure. There are some atoms that they can share electron. So heavy atom has the way they behave, especially when they are bonding with another atom. Please, are you getting it? There are some atoms that they can donate electron pairs. And all these electron pairs, all these characteristics makes or gives the uniqueness of each chemical bond that we have. There are some chemical bonding, like the ionic bonding, that what only occurs is transfer of electron from one atom to the other ones. There are some chemical bonding that what happens is just sharing of electron, because what the atoms does is just that there's sharing of electron between one atom and the other. There are some another chemical bond that what happens is just donation of electron pair. These are the dative bond, the coordinates, covalent coordinate bond. And there are some another bonding that what occurs is movement of electrons. Electron moves freely. This is the metallic bond. Please, do you get it to this extent? Please, are we all clear to this extent? Now, do you understand why we are doing chemical bond? Lillian, are you with me? Titi, do you get it? Number one, I want you to understand that atoms want to become a stable octet structure. They want to have a nature like the noble gases, like the helium, like the neon, like the argon, like the krypton. Is that taken? And the xenon. So they want to have these stable noble gases. Now, how do they have these noble gases? Until they bond together, they cannot have these stable gases. Now, when they bond together, there are some atoms that they can transfer electrons. Because we would have just one type of chemical bond. But the reason why we have different type of chemical bond is because there are some atoms that they cannot share. They can only transfer. There are some atoms that they cannot transfer. They can only share. There are some atoms that they cannot share. They can only donate. There are some atoms that they cannot transfer, they cannot share, they cannot donate, but their electrons can move and attach to the metallic structure. Please, do we all get that concept? So now, let's take it one after the other. Let's start with the ionic bond system. Let's start again. Yes. Let's start with the ionic bond. I gave you a note last week. Should I still give you the note? I said in the last class that ionic bond occurs when electrons are transferred from one atom to the other. isn't it? Please remember. Hello, are we there? It involves the transfer of electrons. Let me just write it down for you. From one atom to another. Do you see this now? Now look at the table that I gave to you here. Can you see the table I gave to you here? We said there are some atoms. Okay, you have the notes. Thank you. So everybody, you have the notes, right? There are some atoms that can transfer the electron, right? The any atoms that can transfer electrons are found in the ionic bond, and it is usually between metals and non-metal. It is usually between metal and non-metals. Is that taken? Between metals and non-metals. Now, what will the metal does? The metal will lose the electron. And I told you last week that metals are always the one that have positive ion. Anytime you see Kinikon plus, something plus, like Na plus, Mg2 plus, Li plus, Al3 plus, they are metals. What does metal does? Because anytime you see plus as a plus electron, the number of electron it has lost is equivalent to the number of the charge it has. If you see Na plus, it simply means sodium has lost one electron, right? If you see Mg2 plus, it simply means magnesium has lost two electrons, right? If you see aluminium, Al3 plus, it simply means aluminium has lost three electrons. Please, is that taken? So ionic bond occurs between metal and non-metal. Please, is that taken? Metal and non-metal. So the metal will lose electron. The metal loses electron, and they are the positive ion. Please don't forget that they are the positive ion. Why the non-metal, they gains electron? They gains electron, and they are the negative ion. So that means there is an oppositive charge between. Oh, don't start again this thing. So this is negative ion, right? So there's always an oppositive charge attraction. The opposite charge they attract, positive ion, negative ion, between the ionic bonds, metals and non-metals. Now let's go to the example. This is where you need to pay attention the most. Let's start with sodium chloride. Maybe you get it to this extent, right? Uh, sorry. Sorry for that. So let's check the sodium chloride as an example. NaCl. Now, do you remember how many electrons does NaCl has? when I was teaching you the other time. NaCl means Na plus plus Cl minus, right? And sodium belongs to is the element 11 in the periodic table, isn't it? Please, are we here?
Yes, 11.
Okay. So now, if you are writing sodium, that's 2,8,1. I don't know why. I just finished using this. Why is it that why I start teaching it? Start basically. It's 2,8,1. So it simply means we have one electron at the outermost shell for sodium. If you are writing it using the dot formula, that's 2,8,1. So we have 2 here, right? For the other one, we have 8. 1, 2, 3, 4, 5, 6, 7, 8. Please, let's be fast. And the outermost shell, we have 1. You can see that between sodium gaining 7 and losing 1, which one is more easier? Losing the 1,
Losing
right?
one.
In order to have the octet structure, if it loses this one, this third shell will not be there again. So it remain 2,8. Are we together now? So sodium will rather transfer, this is sodium here. Sodium will rather transfer this one electron to chlorine here. Now, if you look at the chlorine belongs to element number 17. That's 2,8,7, right?
Yes.
If you still remember. So that would be 1, that would be 2, and the third one, that's 3. So it simply means that we have, oh, why is this system doing like this? Please manage my diagram for now. So that means we have 2 in the inner shell, 8 in the middle shell, 1, 2, 3, 4, 5, 6, 7, 8. And we have 7 in the outermost shell, right? That'll be 1, 2, 3, 4, 5, 6, 7. Please don't mind my diagram. It is this thing that is misbehaving here. Please, do you get it up to this extent? This is chlorine, right? So that's 2,8. What is all this? So this is chlorine. Now, chlorine needs 1 electron to have the octet rule. Sodium wants to donate 1 electron to have the octet rule. That is why sodium chloride is an example of ionic bond, because one is donating, one is receiving. And at the end of the day, you will have something like this. It will become something like this. 1, 2 for chlorine. For sodium, sorry, for chlorine it will become 1, 2, 3. So this one we have the 2 inside there and the 8. So instead of sodium to be 2,8,1, it will become 2,8, right? So then we have something like this, which shows that it has donated 1 electron. That's Na plus. Please, are we together? And chlorine, we have the octet structure also, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You can see instead of chlorine to be 17, it has become 18. So then you put inside the box and you write minus. Minus 1 simply means it has gained 1 electron. So this is a compound that we call NaCl. And that is ionic bond. Please, do we all get it? So it is very simple. In ionic bond, it is just a metal and a non-metal. That is, there must be a transfer of electron from the metal to the non-metal. The metal does not need anything again. Does not need anything again at all. It's just as if gift is going inside the exam hall. Let me say, for example, gift is going inside the exam hall now. And they said every student must come into the exam hall with 1 pen, 1 pencil. If you are caught with 2 pen, 1 pencil, you'll be penalized. And gift has forgotten eventually that the instruction says that they should come to the exam hall with 1 pen, 1 pencil. But she picked 2 pen in case 1 pen stopped working and 1 pencil. And as she gets to the exam hall, maybe Lillian only came with 1 pencil. She forgot the pen totally. She thought she had picked it, but she forgot. And immediately Gift saw her hand. She said, and the examiner said, you cannot enter. You are not serious. We asked you to come with 1 pen, 1 pencil. And so what we Gifts do, Lillian is looking for 1 pen. Gift does not need 1 pen. Gift will give Lillian. Gift will enter. Lillian will have 1 pencil and 1 pen. Lillian too will enter. They get it. So that is what is happening in ionic bond. One atom is donating because it has in excess. Another atom is receiving because it needs to have the octet rule. It does not have. It is deficient. It is deficient of some numbers of electrons. Please, do we get the concept on that ionic bond? Is it okay? Very good. Now, if you check another one, MgCl2, it is also the same thing as this. MgCl2. It's also the same thing. Mg, yeah. That's element number 12, right? If you remember, that's 2,8, 2. And Cl, just like what we did now, is element number 17. That's 2,8, 7. So this Mg, look at it now, want to donate these 2 electrons. This chlorine, you know, we have 2 chlorine. You know, it's Cl2. That's 2,8, 7. This one need 1 electron, isn't it? Oh, this one need 1 electron. So this Mg is donating to these 2 guys here. So Mg will remain, it will become 2,8. 2,8 is not an octet structure. It's an octet structure. Please, are we together? 2,8 is an octet structure. Look at this one now. If Mg donates the 1 electron first to this one will become 2,8, 8. And if you donate the other electron to this one, it also become 2,8, 8. Can you see? Cl has become an octet. It has the octet structure. The 2Cl has octet structure. Mg has octet structure. So if you are writing this one now, it will be 2,8. When you draw the circle, because in case you see the option, it must have +2. If it does not have +2, it is not correct. So don't pick that answer as your option. For example, what do I mean by that? Let's say they draw something like this. 1, 2. And they put 2 electrons here. And they put 8 electrons here. And they did not put anything in the box. Please, this is not Mg2 plus. Please, are you with me? After doing something like this, they must put 2 plus here or +2, anyone. Please, do you get it? That is your correct answer. And for your chlorine, it will be Cl minus Cl minus. You will draw the two chlorine structure. And if you want to draw the three together, it will become this Mg will be in the middle. The one Cl will be at the left and the other Cl will be at the right. Is that okay? But always remember to write 2 minus. If you are drawing this thing has started again. That's 2 minus. You will draw the 2 minus 2 times for the chlorine, the first chlorine, the second chlorine. And if it is also MgO2, hope you know that magnesium oxide also is an example of ionic bond, because magnesium is donating 2 electrons to oxygen and oxygen is receiving the 2 electrons. Please, do you get the concept of ionic bond now? Is ionic bond very clear now? Are we all clear with ionic bond? Thank you. So let's go to the part B. Sorry, let me start my chalkboard. I don't know why this is. So I believe you guys are getting it already. So the covalent bond is actually different from the ionic bond that we just did now. Sorry. Trying to. Somebody asked something in the book. As it belongs to you guys started. Is it you're not serious? Are you just coming? What time are you supposed to be in the class? So I believe you guys understand ionic bond easily now without any issue. Now let's go to the second one, the part B. And that is the covalent bond. So the covalent bond, like I said, is actually different from ionic bond. I gave you the notes in the last class. Covalent bond just talks about when atoms share electrons within themselves. Many of the time, it's always between non-metal and non-metal. Are we together, please? So it entails the sharing of electrons, not transfer of electrons, sharing of electrons. Sharing of electrons, usually between non-metals. That's the note I gave to you in the last class. Sharing of electrons usually between two non-metals. So in this case, what happened is that, non-metal likes receiving electrons. That's the non-metals, they are like ladies, they like receiving money, they like collecting money from guys. So they like receiving electron. But there are some non-metals that they cannot attract other metals. So maybe let me say TT and gifts, for example. Now they do how will I put it now? They are friends together. Then I said, okay, give me 100 naira. Let's be saving 100 naira every day. So in a month, we save, 3,000 naira. But you guys are poor. So let's say you are saving 1K every day. In a month, that means you are saving 30,000 naira approximately in a month. So you are cooperating together because you don't want to call Eze, give me money now. Paul, how far now? Paul will say, Abba, how will I give you money? Me to say, I did it for money. So covalent bond is just like non-metals coming together to share electrons within themselves in order to have the octet structure. That is just the aim. So you could not see metals and non-metal forming covalent bond. Like I say, metal like giving out because metals are positively charged ions. Do you remember? So they want to lose that electron. If you remember lithium belongs to it's not element number 3. That's 2,1. You know, lithium we want to lose that one electron. So lithium is looking for a non-metal to give that one electron. Potassium, element number 19. Do you remember? That's 2,8, 2,8,1. So potassium, we want to lose that one electron to a non-metal so that it can have an octet structure, which is 2,8,8. Same thing as calcium. Calcium, we want to have an octet structure. You know, it's 2,8,8,2. Do you get the logic now? But covalent bond, they want to receive electron, but they don't want to partner with a metal. They want to do it within themselves. Lillian and Titi, they want to share money within themselves. Titi and Give, they don't want to share money. They don't want to look for any guy at all. Let us make money on our own. We can be a lady, we can have money, we can be wealthy, we can be like Okonjo Weller, things like that. So that's their own motivation. So that is just covalent bond. Anytime you see sharing of electron, oh boy, that is covalent bond. And anytime you note that this is non-metal, if it is between two non-metals, it is a covalent bond. Please, do you get the logic? Now, let's say, for example, which example can I give you? Please, do you get it now? Let's say between two hydrogen. Hello, are you guys with me? I can see your reaction. All right. So let's say, for example, I don't know why this thing is dragging. Oh, give me 1 minute, so 5 seconds. I should explain again. Easy. Easy, we can't go back. Oh. We have a lot of things to cover. Just go and check the video after the class. Please, are we together? Now, we are talking about I want to use hydrogen as a case study for you. Now, if hydrogen want to bond together, hope you know hydrogen can actually behave as a metal or as a non-metal. But in this case, hydrogen is a non-metal. Now, do you remember how hydrogen is formed? It's element number 1, right? Isn't it? So if you do something like this, so we have something like this for hydrogen. You know, it has 1 electron plus it says 2 hydrogen. Majority of the time, anytime you see diatomic molecules, 90% of the times they have covalent bond. Please, you get the logic? Because only non-metals can form diatomic molecules. So that means 2 non-metals are combining together to share electrons. That is the case of hydrogen gas, oxygen gas, chlorine gas, and all. So let me just pick one out of the diatomic for you so that I can explain. You can see hydrogen has 1 electron, right? Which is the red color. The second hydrogen also has 1 electron, which is the red color. Now, they are reacting together. They're reacting together here. Look at what they will form. This is 1 hydrogen here, right? This is second hydrogen here. Don't mind my drawing. This thing is giving me a headache. This is second hydrogen here. Now, there are 2 ways to draw this thing, but let me teach you the first one. We have 2 electrons. This is just like a set theory that they are sharing together. You see some textbook, they will do it like this. This is the first hydrogen. It has 2 electrons now, which is complete. This is second hydrogen. It also has 2 electrons, which is complete. Another diagram, we put it like this. Another textbook, we put it like this. The first hydrogen, we have the first electron here. The second electron will be here. And the second hydrogen will be bonded to this place. Any which one is correct, depending on how you see it. So the first electron of the second hydrogen will be here. So, sorry, I've made a mistake. I made a mistake there. So you know they only have hydrogen has 1 electron. So the 1 electron, let's say the second hydrogen is also combining here. This is so the 1 electron of the first hydrogen is the color red. Do you get it? The second electron of the second hydrogen, let's call it color blue. Now, if you look at the hydrogen, the first hydrogen here, and the second hydrogen here, let me call it color red so that it can be well explanatory. You can see that the first hydrogen here, one way or the other, it has 2 electrons at the outer motion now. It has 1 red and 1 blue. It has half the octet structure already. Look at the second hydrogen that is color red. It also has 2 electrons at the outermost shell, 1 red and 1 blue. Now, how does it get the 1 red and 1 blue? This one is sharing it with it. This first one that has color blue is saying, I'm not leaving this thing, no. I'm not, but I can share it with you. We can share it together. You too. Just as, okay, let me use Titi and Gift again. Titi has Gary. I don't know if she likes to. I don't know if she like Gary. She has Gary, and no, Gift like have Gary. That the one we like food the most. Gift has Gary, and Titi like has maybe granuts. And Titi was like, if I start saying I should be eating granite alone now, I will not be satisfied. I will still be hungry. And Gift is like, how will I be taking Gary alone? I'm a two girl now. It's not possible. I need something to spice it up. So I need an appetizer. And Gift just look at, okay, just go to the WhatsApp status. Hello guys, how are you? There's an update to I have Gary. I'm looking for someone that has granuts. Let us share now. And Titi just be like, oh, thank you. I've been looking for someone that has Gary, me to have granuts, and they collide together. And they meet at a point, at a junction. Say, okay, give me your Gary, let me give you my granuts. And they share the Gary together. They share the granite together. At the end of the day, Titi went back home full. Gift also went back home full, smiling. And I know Gift, after eating, she'll be smiling. So that is what is happening in the covalent bond. Do you get the logic now? Covalent bond is just like they are sharing electron. No one is releasing the electron fully, but they are sharing it in order for them. So anytime you see something like this, that they sharing of electron between 2 non-metals, it is covalent bond. Same thing as oxygen. No, let me quickly do oxygen so that will give you let me give you oxygen. I believe you guys should be able to write oxygen yourself with the explanation so far. Oxygen is 2,6, right? That would be 2. Oh, this thing has started again. That would be 2,6 plus 2,6. You can write it in your notes. I believe you can do it yourself. So the first shell has 2 electrons, Abi. The second shell has how many electrons? Is it not 6? 1, 2, 3, 4, 5. Let's put it here. 6. This one also 2, 2. 1, 2, 3, 4, 5, 6. This one is not complete. You know, to have an octet rule simply means there must be a complete electron in the outermost shell, right? If you look at the first shell, we have 6. Is it complete? No. If you look at the second oxygen, so it's not complete. They need 2, 2 at the outermost shell, isn't it? So this is what they will do. Oxygen, the first oxygen we release the O2. I don't know which one do you like. Do you want us to be using case A or we'll be using B? Which one do you want? Or we should be using the two? Which one do you prefer between A and B? Let us be using B. So now let's say, for example, now we want to combine these together. You know, we have first shell, the second shell. We have first shell here. We have the second shell here, isn't it? Don't mind my handwriting. We have 1, 2 here. We have 1, 2 here. So we need 6 eventually. So we have 1, 1, 2. We have 1, 2. We have 1, 2. So this one also will release its own. 1, 2, 1, 2, and the 1, 2 here. These are all together. Now let's count the outermost shell for the first oxygen. We have 1, 2, 3, 4, 5, 6, 7, 8. Same thing here. This has become an oxygen molecule, which is O2, right? This has become hydrogen molecule, which is H2. Because the oxygen, they are sharing the electron within themselves. Please, do we get it? Please, do we all get it? I believe you understand covalent molecule now. It's just sharing of electron between two molecules. I don't want us to waste our time because we've not even moved to today's class. Now, can somebody do water for me? Why water is regarded as a covalent molecule? Can somebody do? Can somebody do it, or I should continue? You all know it, Abi. Should I continue, please? Please answer me because of our time. You all know it. Okay. Very good. So, okay, let's move to the. You didn't get the question. The question is that you guys should draw how water is a covalent molecule, H2O. We have hydrogen. Even sorry, even for the hydrogen. It will be here. We have oxygen. Apart from the inner one, we have 6, right? We have 1, 2, 1, 2, 1, 1, isn't it? And we have the other hydrogen here. The other hydrogen also has its own electron, 1 electron. So this is hydrogen, this is oxygen, this is another hydrogen. You can see hydrogen has 2 electrons, the black and the red, Abby. You can see oxygen has 8 electrons at the outermost shell. That's 1, 2, 3, 4, 5, 6, 7, 8. You can see this last hydrogen, the color blue, has 2 electrons at the outermost shell, right? Which is 1, 2. Can you see it is very simple? Okay. Please, do we all get that? TT, do you get it? 4. Okay, very good. So because of our time, let's quickly move to another one. I gave you all the properties last week, Abby. I don't need to give you properties again. I hope you've written it down. So let's go to coordinate bond. This one is where issue can come. So if you remember what I told you under covalent bond, I said covalent bond is formed when two atoms share electrons, isn't it? Isn't it? Please answer me. Now, coordinate bond is a type of that covalent bond. Also, two atoms are being donated, but the shared pair of electrons is coming from just one of the atoms. So it looks like covalent, it looks like ionic. You know, in ionic, there's transfer of electron from one single atom. In covalent, there's sharing of electron. Now, in coordinate covalent bond, that electron, that pair of electrons is coming from just one of the atom. The atom that is sharing that electron is what we refer to as, is it not ligands? I don't know if you know ligands. So let me just break it down for you. In covalent bond, it is sharing of electrons. In coordinate bonds, it is not just sharing of electrons. The electrons that, the atoms that is sharing electron, the electron is coming from just one atoms, one of the atoms that are coming together. Let me give you some examples. Probably you will understand. So coordinate bond is just a special case of covalent bond where one of the atoms is the one that is sharing the paired electron. Do we get it now? One of the things you should look for in coordinate bond, it is very common. The common ligands that JAMB always asks question on is ammonia, water, and the halide ions. But that's not just it. The most important thing is for you to understand what coordinate bond is. Let me just use a case study. Let's say we have an atom A. This atom A contains, let's say it has, I want you to pay attention to this aspect. It has 1, 2, 3, 4. Let's say we have 5, 6, 7, 8. And we have another atom, which is B. Let's say this B has something like this. This coordinate bond is somehow confusing, but don't be confused. Let's say it has 1, 2, 3, 4, 5, 6. Do you look at this one? Do you see that it has 8 electrons in the atmosphere, right? Apple. Look at this B. It has 6 electrons, right? Now, this is an example of a lone pair that I'm talking about. Let me paint it red so that you can see it very well. Now, we have something like this. I think the first one is blue, I mean. Let me use blue. So this A, for example, here. We now have something like this. I think I use red for the electrons. 1, 2, 3, 4, 5, 6. Now, look at this electron here. This is the lone pair of electrons that we're talking about. This A will now be sharing it with this B. But still, A will still be using it. Do you know B does not have it at all? Now, B will become an octet structure. A will still remain an octet structure. But B is not donating anything, unlike covalent that the two of them are donating. Please, do we get it? Hope it's not confusing. Linear, I'm not seeing your thing again. Now we have something like this. Gives alpha, Titi alpha. Okay, nice one. So we have B here, isn't it? Now I use blue for the electrons. So let's say we have the 2 here, the 2 here, Let's say we have the two here. Now, this red, which is for A, we have the two here. Can you see A still has the octet structure, isn't it? B also now has octet structure, isn't it? But let me ask you a question, Gift. Is B donating anything? B is not donating anything. Yes. But it has become an octet. Unlike the covalent bond. Do you remember in covalent bond? If it is covalent bond, you know A and B will donate together. Now, do you now understand the difference between covalent and coordinate covalent bond? That is just the simple difference there. That's just it. So after this class, just look at different probably you can go online and look for different questions or different examples and practice it, how you can form the structure yourself. Let me quickly do one. Let's do probably ammonium ion, NH4 plus. But we've not done anything to this class at all. So okay. So ammonium ion, NH4 plus, you will see NH3 plus and hydrogen ion. They are coming together to give Na4 plus, right? Now, how does it form? Nitrogen is 2,5, right? Let me just draw the last electron shell. Let's say we have two here. 1, 2. Isn't it? We have 1 here. We have 1 here. We have 1 here. This is making it 5, Abi. That's 2,5, isn't it? And the 3 hydrogen here, they are bonded together. Let me use blue. Let's say they are bonded together like this. So can somebody tell me what type of bond is existing between ammonia with this diagram alone? Hello? Can you guys hear me? Ammonia is covalent. Yes, thank you for that. Now, how is it covalent? Look at it now. You can see hydrogen will donate a bond to this one. Hydrogen will donate a bond to this one. Hydrogen will donate a bond to this one. All these ones, they are hydrogen, hydrogen, hydrogen. This, are you getting it now? So this is how ammonia is formed. 5 electron comes from nitrogen. But nitrogen needs 3 electrons to become an octet structure, to have this noble gas structure. Now, hydrogen. Nitrogen go and meet hydrogen. Alpha now. Guy, they suffer. I get something. I get 5 things for her, but I need 3. I don't be like, guy, me too. I need one hydrogen we talk say I need one, no. Another hydrogen say I need one, no. Another hydrogen say I need one, no. Yeah, let's come together now. Let's be living together. So that's what happened. You can see that they have an octet structure now. Now, the hydrogen here, which is H plus, because this one is H plus here. So what will it have? To have something like this, right? So this plus simply means it has lost electron. Are we together? So with this, why is this thing stressing me like this? So with this alone, we can form our NH4 plus. How do we form NH4 plus? This hydrogen here You can see that it does not have any electron at the outermost shell. It does not have anything, isn't it? So what will it do? It will pair. Now let me draw this ammonia again. I hope you guys are getting this thing. So under the ammonia, we have these are the things we have the last time. We have two red here. We have one red here. We have one red here. And we have one red here. And we have green here. So why is not giving green? We have green here. We have green here. We have green here. Isn't it? Now, we use blue to attach hydrogen. Hydrogen is attached to this one. Another hydrogen is attached to this one. Another hydrogen is attached to this one. Isn't it? We need to attach this oxygen. Now, nitrogen has a no pair of electron here, right? Look at the top here. It can share with anybody without receiving anything from anybody. Gifts, do you get it? Because at the last place in the shell, it is looking for electron that, imagine, I don't need your money. I have my own money. But I just said, Abba, you are a good person, or let me just help your life. I can ask you to come, yeah, you can be living with me. Do you get it now? So this oxygen here, this hydrogen here can now come and say, Mr. Ammonia, please now, let me be living with you. At least hydrogen is already living with you before. Another hydrogen is already living with you. About 3 hydrogen is living with you. Let me also join now. Let us make it 4. And the maximum hydrogen that nitrogen can contain is just 4. Say, okay, no problem. I can still give, I have 4-bedroom flats. I can still give you one room out of the 4-bedroom flat. But after this one, no, I'm not accommodating anybody again. I said, no problem. Nobody will come again. Nobody will come again. Then nitrogen will come, the hydrogen will now come here and fill this place. Please, do you get it now? Can you see that the hydrogen has now become how many? 4. And that is how we have NH4 plus. NH4 plus. Please, do we all understand? I don't know how many people that are in the group are in the call. I shall notice is there, Gift is there, Lillian is there. Who else? Paul is there. Izzy, are you still there? Okay, who else is there? I did not mention. Is Suzanne there? Suzanne is not there. Mintu is not there. This guess, if I catch them, it is well. Oh. So I hope the people here, I hope you guys understand dative bond or coordinate covalent bond now. So it is very simple. So let's quickly move to another thing. After the class, just go and be practicing questions. You can check ammonium chloride, ammonia chloride, check there are different examples of coordinate bond. You can do it yourself. It is very, very simple. Very, very simple. So which one else should we check? So in every you can see that coordinate bond, it behaves like covalent bond. But in one sense, it's not covalent bond because there is this one that has extra electron that has the octet structure already. But what's just doing is I just helping people's life. Let me help you now. Let me help you now. Let me help you now. But as it is helping, it's not releasing like ionic bond. You know, ionic bond will release. Yeah, collect, be going. I don't want to do anything with you again. But coordinate will say, I will help you, but you must stay with me. Do you get it? And coordinate and covalent. Do you get the difference now? Ionic will say, like sodium now, sodium will say, let me give you 1 electron. Let me give chlorine 1 electron. Yeah, chlorine will be going. So sodium will become 2,8. Chlorine will become 2,8,8. So they will be going on their way. In covalent, the 2 of them will be living together, but the 2 of them will be sharing electron. TT and Gift, they are sharing food together. So TT is contributing 15 naira. Gift is contributing 15 naira. They are sharing it together. But in coordinate covalent bond, they are living together, but only maybe TT is the only one giving Gift money. And Titi is not complaining because she has more than enough. They are collect 15 naira now, collect. But Titi is telling Gift, don't leave my room, oh. You must not leave my house. If you leave my house, everything you've eaten, you will vomit it. So that's just coordinate covalent bond like that. So the next one is metallic bond. It's very simple. So this one is the most simple one. It occurs between metals. Like the electrons of one metal will be bonded to that metal. Like the sharing of free electrons among positive charge metal ions. I gave you the note the other time. Sharing of free electrons among positive charge metal ions. That's the ah my so sharing of electrons between positive charge ions. Oh my god. This thing has started again. This is what. Oh my god. So the let me just use my mouth to explain that one. The metallic bond is very, very simple. Oh god. I have to write. Just give me 5 seconds. Let me set that. Oh god. Sorry for that, guys. I'm sorry. So, oh my god. Is this oh my god. This is frustrating. God. Oh my God. Oh my God. Can you guys see my screen? Oh, I can't work on it. Sorry guys, the board is not responding here. That's what I'm trying to sort. I'm so sorry. Ah, God. All right, so let me just continue. So metallic bond just talks about sharing of electrons with sorry, let me try it again. This is actually frustrating. I don't know why it is saying I can't share. Okay. Sorry guys, I can't share my screen again for now. Don't know what's going on. No, just give me 1 minute. Let me restart my entire system. Just 1 minute, please. Please, I'm coming. Please don't leave. Oh, I'm coming. 1 minute. All right. Sorry for that. Well, please, I hope you understand the chemical bond now. I'm so sorry for the breakage. I had a class this morning and there was no issue. I don't know why there's always issue when I start a class. Maybe because the load is too much. All right, so let's Let's continue. Let me. All right. It's working perfectly now. Working perfectly. So let's leave today's class. The last class. Let's go into another thing. Is there anything that we did not check? Is there any bonds? So, like I said, metallic bonds exist between metals, right? That one is a most simple one. So, anytime you see potassium, uh, you know, maybe potassium, copper, anytime you start saying anything metals, all right? Maybe iron, maybe copper, maybe aluminum, maybe sodium. That one is metallic bonds. You know, in metals, electrons can move freely. So as the electrons are moving freely, they are binding with the metal. So when there's sharing of electrons among a positive charge metal ions, that is metallic bond. The next one we have is the hydrogen bond. Is the hydrogen bond. So hydrogen bond talks about a weak attraction between molecules. And it occurs when hydrogen is bonded to electronegative elements, especially nitrogen, oxygen, or fluorine. These are the high electronegative elements that we have. So that is hydrogen bond. And that is the last bond that we're expected to, to do. Please, are we all clear for the so the where the issue will come from is that they will be testing you is especially on the coordinate bonds. If you are lucky, they will ask you question on covalent bonds. They ask question on ionic bonds. Majority of the time, they don't ask question on metallic bonds because it is a very simple bond. And by now, you should be able to identify which one is hydrogen bond, which one is not hydrogen bond. Hmm? So let's play more to today's class. In fact, our time has gone on. But at least we can say that we're able to understand everything under the chemical bonds. Or do you have anybody that doesn't understand anything? So there's this place that Jump also loves. Let me just write it out for you. I will send you this note after the class. So I was unable to write properly there. It's shapes of simple molecules. Just memorize it. For my own little research, I quite understand that Jump don't have more than this don't have more than these molecules and their shape. So if I am you, I will just if you are me, then you just cram these 5 molecules. You should know what is when we say a molecule has a linear shape. You should know all those things, right? Entity. So I'm not like that. So let's move to nuclear chemistry. Should we proceed? Sorry for the break. Do you like the break or you don't like the break? So with your activity. Titi, okay, you asked me there's this part you said you want us to do, I think, or the oxidation, the reduction, isn't it? So when it talks about radioactivity is talking about how uh, some unstable nuclei, how they emit, that is the spontaneous emission of radiation from unstable nuclei. That's radioactivity. Let me just give you the spontaneous emission of radiation from unstable nuclei. Ewo. See, I started again. So in case they're asking you about the symbol, where we are going actually is the half-life. Lillian, I see you. I got you. So where we are going is the half-life actually. But before we get there, there's this thing I want you to write down. The charges of the alpha, the beta, and the gamma, and the penetration. Let me just find a way to, because they ask question on this also. Please, I want you to write it down. So I think we should firstly look at question and answer on chemical bond before we get. Here is the next question. That's the next thing in your syllabus. They want you to know the composition of air, separation of air, and the use of noble gas. This one is just notes. You have to go and read it. I'll just pile up a notes for you. I will send you a summary. Just read it and assimilate it. And after the class today, I will try and create a video for all your topics because I'm sure we'll not be able to finish the syllabus. So once I'm done creating it, I will notify you on the group so that you can go to your dashboard and download or watch the videos. Is that it? So half-life simply talks about the time taken for half of a radioactive substance to decay. Talks about the time taken. Let me look for first question. The time taken for half of a radioactive substance. The time taken for half of the radioactive substance to decay. The time taken for half of a radioactive substance to decay. Okay, before we move on, let's quickly move to Let me look for some questions. We have 5 students in the class, Abi. Justice, he just joined. Your you guys did not even remind me. Your last quick test, we did not do the solution. At least many of you did well in your chemistry test, your chemistry. Eze, you did not participate. Is posted there?
Sir, I participated. I was the one that took the last position.
Okay. You guys will do your own makeup test. I think gift you had 16 or 17. It's 17. It's not 19. It's plenty of. What would you not give me?
Is it me that will give you, Abi? You that will give me?
I know you like money. At least you should give it. I think you should give me something. Yeah.
Who doesn't
Okay.
like me?
God did not like money.
Like,
How Paul do you like money? God doesn't like money. Okay, let's check some questions first. So I'm starting with Lillian. This question is a very stupid question. I'm very serious. Yeah, it's a very stupid question. I'm sorry to say. I don't know why Jam would be asking this kind of question. Lillian, what's the answer? Lillian, Lillian, are you still there? Can you guys hear me? Lillian, what's the answer? I'm not even expecting you to think on this question at all. Thank you. Why are you not talking this time? Do you guys remember this song?
nothing.
Vivian, Kinika, Vivian. I've forgotten the song. Vivian, anytime I see Lillian, I remember that song. Lillian, oh, Lillian, oh, Lillian. Okay, you can see the question is, what do you say, Lillian?
I said it's a French song.
It's a sweet song,
It's a French song.
a strange song.
A French.
Okay, French. Okay, oh yeah. Can you speak French?
Yes.
Yeah. Come and teach me French. I will enter your DM. Yeah. All right
Okay.
now. So Justice, answer the second question. You can see that first question is actually not a good question. Why would they be asking the type of bond that exists between Justice, answer the question. Justice, are you with us or you are against us?
Okay, I'm with us now.
So what is the answer?
Mm,
Were you in the class?
no, I went to do something, but I think it's C. C.
It's C. It's very simple to know. Very good. Do you guys still remember this question? I saw it now. I remember I taught you guys, and I gave you a table. Do you guys still remember? What's the answer? Gifts.
Atomic radius.
Increase across a period. Are you
Wait,
sure?
increase. Okay, wait. Across a period is
Increase across a period.
there is electronegativity. Sorry.
Electronegativity. So, A is the answer to this question.
Jimmy.
Easy, easy.
Okay.
Is easy still there?
I'm here. No more. I think it's B tetrahedra.
What do you say?
D.
The tetrahedra. Very good. All this question is actually just go and look for more jam question. The ones I'm seeing here, I don't know. It's very simple. I don't know. Maybe it's me. It's me looking at it. Paul, what's the answer? It's too simple. Paul, what's the answer? Gift, what is the answer for the next question?
B. Ammonia.
Ammonia. Very good. Paul, are you still there? Linear, answer this question.
Can I answer
Paul,
for
we are waiting for you, Paul.
Sorry, sir. I had to quickly attend to something.
Okay, answer this question. Question. Which one is that? This one. This question is actually too simple. I don't know. You should be able to score almost everything in here.
Sodium chloride. Sir.
Yeah. What do you have in your chemistry test? What's your score?
I think I had 15 or so.
15. Okay.
Let me check it.
Okay, where are we? I said Lillian to answer the last question. Lillian. Lillian.
Lilian. Oh, Lilian.
Oh,
Do that.
my- Is Lillian still here? That guy. Are you watching cartoon already?
G.
Ionic compounds.
Oh no, no, no.
Suzanne. 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 How many times have I called you? Enter my DM after the class. I did not call you 5 times, so I call you 3 times. I will flog you today. One lie. So, Lina, what do you call the answer? You said D or what?
I said B, B. Good electrical.
Okay, I thought you said D.
No, 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 no.
Okay, that's good. Who's the next person? Justice, answer this question. This one is very technical. I gave you last week actually.
It should be ionic bond.
High boiling point of water. I don't think ionic point dictates
They
the
say it
boiling
has
point of water.
high and melting, high boiling point.
That
and
one is
melting.
high metal point. Huh?
He says it has a high melting and boiling point. Unless it's not in water.
Yes, I said that. Said the type of bond responsible for the high boiling point of water. Of water. This is underlying water. It's just a
Covalent.
tricky question. Oh. It's a very simple question. But I know many of you will jump to ionic bond. The answer is hydrogen bond. Exactly.
Yeah, yeah, yeah.
Hydrogen bond occurs between water molecule and it increases its boiling point. And that's why water boils at 100 degrees. Please, all of you guys, do take note of that in case they ask you that. People will just see boiling point of water, high boiling point, high boiling point, high boiling point. Since ionic bond has high metal and boiling point, just go and pick ionic bond. Please, share it, bro. Gives, do you hear Yoruba? Linear, do you hear Yoruba? Ah, I will teach you. So who is the next person? Is that easy? Easy, are you there?
So I'm there. Let me analyze the answer. The options are coming.
Easy, we are waiting for you. I want to give you a question. The question is very technical, but it's very simple. You understand small, small?
Try
No,
us.
I will teach you, but you will pay me. I don't want to pay. You want to learn for free. Who is planning to study around this side? Like you plan to study here, or everybody want to study in the east? Who is going to Uniben here? You want to apply to Uniben? So the Yoruba side here. They are studying in Abuja. That's good. Gifts don't want to come. No problem. Assuming you come now. All right. So Eze, we are waiting now. Should we continue?
Sir, I'm kind of skeptical about this thing. The positive ion in itself, the
The metallic
colorized
bonding.
electron. Metallic
I told you.
bonding.
Okay, attraction between molecules. What? Which bond creates attraction between molecules? Anybody that can help us? Sometimes when you don't know the answer, you can use your option to get your answer.
So it's ionic bond.
Anybody here is attraction between molecules. Very good. Transfer of electrons between atoms. What type of bond is that?
Covalent.
Anybody? Transfer of electrons. Transfer of electrons. Not sharing.
Okay.
The ionic
Uh,
bond.
It's the ionic bond. Thank you. Sharing of electrons between atoms is what?
Covalent.
Covalent. Simple. Definitely, that means the answer is C. I told you that there's always this free movement of electrons in metallic bonds. And the end time we call something metal, there's always all these free movements. So that's what we call it creates this kind of C. C simply means plating ions coming together of depolarized electron. So it is metallic bond. So I want look at this question. Answer this question. As Paul answer. Okay, Paul answer this question. Now, this question, they intentionally set this question for you guys. Because if you look at it, don't let me talk. Paul, are you there?
Yes, sir.
What is the answer?
Hydrogen chloride.
Hydrogen chloride. Why is it hydrogen chloride?
Because hydrogen bond mostly occurs within hydrogen and halogens and other negative elements.
Very good. What about is nitrogen to not an electromagnetic? Like
Nitrogen is positive.
what is it?
Nitrogen is positive.
Nitrogen is electropositive.
Yes.
That's
Hydrogen is, nitrogen is +3.
It will gain theory, not lose theory. Have you forgotten?
Okay, that's -3 plus 5. Yes.
That's minus theory. So it will gain theory to become octet. That would be plus theory.
But
So
sir, the oxidation state is variable
it's
for
variable.
group 5.
Yes, yeah, for nitrogen, yes. Yeah, that's good. So now I saw a question here. So give to answer this question. Is Titi back to the class or is it Suzanne? Suzanne, I can't ask you question now because you joined late. And we've learned a lot today.
I don't know. B.
Okay, Ghana City, no problem. Okay, I'm with you, gift.
I said I'm not sure. B.
D.
B.
Why do you say B?
Because NH3 will give us what do you call it, covalent bond, and the
Okay,
remaining hydrogen will bond with chlorine to give us
ionic
ionic
bond.
bond.
Matewo fún ààrẹ. Ìṣèlè yóò yóò bá.
No, this I don't understand this one.
You didn't understand what I said. I didn't
No, I
clap
don't
for yourself.
understand this one.
Oh, I know what to be doing. If I want to abuse you now, I'll be abusing you, but that you not hear me. That's good. All right now. So let's move to another topic. So I sent the jam pass question to you guys on the group for how many years now? Some of you have not even done 30% out of it. It is well. Oh, I've sent it to you guys. It's left to you to do it. So let's quickly move on to another topic. We have 12 minutes to go. Chapter 5, yeah. So this is how we will start the next class. So we are moving to yeah. So in the next class, position of yeah. Talking about the separation of yeah. I'll be talking about the issues of noble gas. These are the things we'll be checking in the next class. And if time permits us, we'll be checking water solubility, acid, base, and salts, acid and base of electrolysis. Where was the question? That's the question Gibbs was asking me. And then organic chemistry. Then we are done. So next class we start with air. So the composition of air, let me give you this diagram. You can just look at it. So the next class, you can see the percentage of nitrogen, about 78%, oxygen about 21%, and every other gases, they're just 1%. You can see. So in case they ask for the components of air, we have 78% nitrogen, 21% oxygen, and 1% for every other gas. And for the separation techniques, that how do we separate it? We use fractional distillation. I taught you some fractional distillation in your chapter 1 when we were talking about the separation techniques. Please remember when I taught you distillation and then the fractional distillation, we have this fractionated column. And due to different temperature boiling, we can separate different components. So once a component reaches its own boiling temperature, it will be separated. Once the other component reaches its own boiling temperature, it will be separated. So should we continue? We have less than 8 minutes. So let's start with what is a year. They will not ask you. Let's continue. Air is a mixture of gases. And please, air is a mixture. Air is not a compound. What did I say? Air is a mixture. Air is not a compound. Please don't forget that. So air is a mixture of gases. I'm giving you the composition. From the diagram, you'll be able to write the composition. So let's start with the first one, which is nitrogen. What is the percentage composition of nitrogen? Can somebody remind us?
I don't hear you.
Yeah?
I did not hear the
78,
question.
yeah, approximately 78%. Very good. The topics again. You mean which one? You mean the one we are dealing with now?
So the topic that you said I was going to treat the next time and the next time. So I'm trying to like
We are
what
trying
are
to
the
write it down.
topics? Yes, sir.
According to your this year's JAM syllabus, which is actually the same thing with the last 3 years JAM syllabus, we are expected to know some topics. So it remains like 6 that we've not actually checked. I said after this year, blah, 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 we should move to water. Then after water, solubility. After solubility, acid and bases. We'll be looking at the theory, the Arrhenius, the Lewis, the Bronsted-Lowry, all those guys. Then we move to electrolysis. So electrolysis is they ask question like 4 theory questions on electrolysis. They ask question on every question, every topic. But there's some topic that they ask more questions there. So in electrolysis, we'll be talking about uh, the reduction, the oxidation, all those jargons. We're checking organic chemistry and nuclear chemistry. But the nuclear chemistry for now, it is just on probability because we may not actually get there. We may not actually get there. That taking Susan.
Yes, sir. I'm taking.
All right. So we are talking about nitrogen, which is the first component of the air. We said it has 78% abundance, like approximately when you check the air. And the properties of the nitrogen, it includes they are colorless and they are odorless gas. They are colorless and they are odorless. They have colorless and odorless gas. So I have a and they are chemically unreactive at room temperature. They are chemically unreactive at room temperature. And they do not support combustion. So you can, these are the major things that actually under this topic, if they don't ask for the components, they ask for the abundance, like a percentage. And sometimes they can ask for uses. Can ask for uses of each component, like nitrogen. Nitrogen is used in HABA process. You know, HABA process is formation of ammonia, manufacture of ammonia. So nitrogen helps in manufacturing ammonia. And it can also help in food preservation. It's an additive that can help to, so it's a preservative that can help in making all these food preservatives chemicals. You can just quickly write it down before we end the class. They helps in the manufacture of ammonia. for food preservation. They can also be used in producing all these NPK fertilizers, nitrogen, phosphorus, and potassium fertilizer. So there are also other ones actually, but let's just end it there. They can be used to fill electrical bulbs. All these electric bulbs contains nitrogen. That's why when it's baking, you hear the sound go. If you don't go, they get it. Gift go go go. All right. So this will be the end of today's class, guys. So we started with back, we end with go. It is okay. We move again. We'll not be tired. We'll not give up. What's the name of this guy now? Don't give up. What's the name of this guy? To be as if you should give up. Lillian, remind me now. What's the name of that guy, sir?
Yakubu.
Yakubu, yeah, thank you. Is that Paul? That's good. You're my guy. You know what is trending? You know what's up? Yeah. So don't give up. Lillian, it will be as if you should give up. Don't give up. Keep reading. Read as if you never read again. Always read at least 4 hours in a day. At least 4 hours in a day. So, Suzanne, you too, don't give up. Oh. Don't be tired. You know, after the exam like this, you have enough time to rest, to sleep. Now you'll be waiting for your results. But what will make the waiting worth it is when you do well in your jam. By the time you see your result, you feel like, wow, I had 290, I had 280, I had 300. Let your target be having 80% in your chemistry. Yakubu manage.
Good money.
Okay, now have 80% in your chemistry. Have 70 at least percent in your biology, your mathematics and physics. Okay, some of you are not doing mathematics, physics and English. Can have 70, can have 80, and all. Sincerely speaking, just target it. But then it requires some commitment and sacrifice. You have to be diligent. Make sure you show up every day. Do the needful. Read. Don't give up. If you feel as if you want to die, or what does Suzanne said? But no, you won't die. Let me go and check her comments. Said you will feel like you want to die, but you will not die. Exactly. Yes, sir. So that's it. So do what to have a good day. We'll be ending the class here. It's already 2:30. I believe some of you want to do something or one thing or the other. So let's do what to. I will send the note to you on your board, on your group now, so that you can go through it in case you miss one thing or the other during the class. Let's do what to have a great day. Justice. Yeah, thank you. Bye-bye. Justice, I need your love emoji. Why are you giving me thumb up? I don't like thumb, I like love emoji.
Manage.
This Shadrach Motors, is he selling motors? I did not see this guy. Don't worry. Yeah, Suzanne, I don't see your love emoji. Lillian, are you trying to do alcohol? All right, that's good. Everyone, take care of yourself. Have a good day and enjoy yourself. Yeah, bye-bye.